In this lecture, we will talk about data, scales, and variables. These three terms are abundantly used in medical literature interchangeably or one in place of another. But it is mandatory to tell you that there are certain finer differences in understanding these three terms. In this lecture, we will exclusively talk about data, what it is actually, types of data, various types of data and their importance, different types of scale of measures depending on the type of the medical data, and variables, definition of a variable and its difference with the attributes. So data is basically any information that is present around us. Traditional definition says that a collection of item or information is known as data. The singular form of data is known as datum. Suppose, let me give you an example. Suppose you are building a structure. For that, you need multiple bricks, right? In this case, the each and individual brick is known as datum. When they are put together one above another to make a structure functional, then it is known as data structure. And this whole building came out of placing the data or putting the data in a meaningful way. There are various types of data as per their origin and then their functionality. Data is basically classified into two distinct types. One is qualitative data, another one is the quantitative data. The qualitative data is basically some intangible form of data which cannot be numerically explained. Suppose you love someone or you like someone. It is a feeling, it is an intangible part of your personality. You cannot explain anyone that how much love you have for someone or how much you like someone. It cannot be quantifiable. Suppose you are giving me an example that my party yesterday was really interesting, but it is not possible to say that how much interesting it was and how much your mind felt it interesting, but you only can describe that it was interesting. There is no numerical values are included in this particular statement. It is a qualitative data. However, the quantitative data says that there must be some numbers, they must be explained by some numbers. The numbers might be continuous or discrete. So quantitative data could be classified into continuous or discrete. Continuous number says, suppose, let me give you an example. Suppose my weight is 62.56 kg. This is a continuous data. Why? Because after a number, there is a possibility of a decimal place. There is a possibility of some numbers after this point called decimal place. Let's suppose height. It might be 4.7 meter, right? How these things works? It might be 2.7 meters, whatever it is, but there is a possibility of decimal place in this number. So it is a continuous data. So 3.269 is basically continuous data. However, discrete data are such type of data where there is no place of decimal numbers, only can be explained by absolute and complete numbers. Suppose here there are 6 dots. So you have to explain that there are only 6 dots. Okay. It cannot be 6.2 dots, right? If I ask you how many males and how many females were there in your meeting last day, you have to explain that there was 42 males and 62 females. It cannot be 42.2 males or 62.4 females. It has to be an absolute number. Now, qualitative data, let me give you a little elaborated explanation of the qualitative data. Qualitative data basically refers to some non-numerical information that describes the qualities. I told you it is also known as intangible attribute or characteristics. Unlike quantitative data, which is measured and expressed in numerical terms. So there is no place of explaining or describing qualitative data in numerical terms. It has to be described by sentences and uh, textual descriptions. So qualitative data is typically descriptive and subjective. It is having a little counterpart of objectivity, such as if you are interviewing someone, some observation you have observed, surveys with open-ended questions, you are asking someone about their feeling of your treatment, about their feeling of pain in diseases. So all these things are qualitative. Content analysis is one of the analysis that we put in the qualitative data to have certain meaningful understanding of this whole data set. And also case studies. You might have come across various case reports that have published in the medical literature. Uh, there are abundance of such reports you will find, but you will also observe that there is no place of any decimal numbers explaining those case studies. It is also describing it is only describing the patient characteristics, the treatment options, and the treatment you have provided, along with the follow-ups and outcomes. So it is explicitly descriptive type of data. Now, what is quantitative data? It's a very easier to understand. I hope you have actually gone through in my second previous slide, where I have explicitly described that data in numerical quantities such as continuous measurements or counts, continuous measurements like my weight around 62.6 kg, and counts like how many males and females were there, and type of the numerical scales like continuous and discrete, described in terms of usually means and standard deviation. We will talk about the central tendencies and dispersion in later lectures. I will talk about what is means, what is standard deviation, what is mean deviation, all of these things. So these are the basic attributes which we actually put to understand the structure of the quantitative data and to understand the whole data that we have collected and express it in terms of certain measures. Frequency tables, histograms are most often used to describe this kind of data as a part of the visualization process. Let me tell you about some fact of scales. Basically, scales are nothing but a standard way of describing the data types that we have just read. Why we will use scale to interpret the data? Because if we interpret the data crudely, then it will be little problematic to analyze those data in terms of the biostatistical considerations. So for this analysis purpose, we segregate data types into the scales. So what type of scales are there? There are basically three types of scales. First one is the categorical or nominal scales, such as gender. Only it is a why categorical? Because there are only two category, male and female, or three category, male, female, and others. So this is a nominal scale. Suppose the jersey numbers in the cricket or jersey numbers in football play. There, if a person is having number 10 jersey, so it doesn't give any significance or information that what this 10 means. It doesn't mean that every time he will go to the pitch and make score of 10 or 10 times of the score of 10, that is 100. So it is not possible to describe that what kind of run he will make, what kind of person he is from his jersey number. So it is just a number to label that cricketer. So nominal or categorical scales are only labeling someone with some scale, with some data point. And numerical or continuous data, it means that when we are expressing something in numbers, these are having three type of scales. The first one is the ordinal scale. Ordinal scale is such scale which is basically qualitative character. However, we are labeling that according to the order or grade. That's why ordinal, the word ordinal comes from the order. It means, for an example, suppose tumor grade, suppose tumor grade, ठीक है. This tumor grading says that uh, carcinoma in situ, uh, and you know about TNM classification, right? Stage 1, stage 2, stage 3, and stage 4. All these stages, from where these stages comes? We know that carcinoma in situ is less dangerous than stage 1. Stage 1 is less dangerous than stage 2. Stage 2 is less dangerous than stage 4. Stage 4 is the terminal. So there is a grading. There is a definite grading from less dangerous to more dangerous. Okay. In a similar way, when someone is asking you about your experience of a product, you are saying that very satisfied, satisfied, not satisfied, or neutral, not satisfied, absolutely not satisfied. So there are 5 grading of the scale. So from very satisfied to absolutely not satisfied, there are definite grading. This is why this scale is purely known as ordinal scale. However, you cannot tell me that very satisfied and satisfied, how much numerical difference was there from very satisfied to satisfied, or how much numerical difference was there from satisfied to unsatisfied. So interval cannot be described from this scale. However, these are described in terms of ordering, from less important to more important, from less severe to more severe, from less satisfied to more satisfied. These are also known as Likert type of scale, which are basically ordinal scales. Okay. Now, another type of scale called interval scale. Interval scale are basically termed as numerical scale but having specific intervals. Suppose temperature in Celsius scale. Suppose I am having a temperature of water 100 degree centigrade, and I have another bowl of water having temperature of 50 degrees Celsius. But you cannot tell me that this 100 degrees Celsius is exactly double of the temperature of 50 degrees Celsius. However, there is specific interval of 50 degrees Celsius, but you cannot tell me that 100 is absolutely double of 50 degrees Celsius in terms of its temperature. Why? Because Celsius scale doesn't come from absolute zero. It comes from the freezing point of 0, which you consider 0 degrees Celsius. However, it is not absolute zero of temperature. So absolute zero of temperature is measured in Kelvin scale, right? Which is minus 273 degrees C. So in Kelvin scale, we can explain absolute zero. So 50K is absolute double of 25K temperature, but 50 degrees Celsius is not double of 25 degrees Celsius. Such as blood pressure. One is having systolic blood pressure of 140. It is not absolutely double of 70. Why? Because this pressure cannot be quantified. However, there is definite interval. But these intervals are not equal. So 80 mm of Hg. Suppose someone is having 90 mm of Hg, someone is having 100 mm of Hg. So 80 to 100 is 10 mm of Hg, it is also 10 mm of Hg. But you're going to tell me that in the human body, these 10 mm of Hg are equal, right? Some of the books, although considers blood pressure as ratio scale, however, I feel that blood pressure is absolutely comes to the interval scale, because there are specific intervals, but it cannot be doubled up. Ratio scale is having a very nice example of heart rate. Okay, ratio scale is having very nice example of heart rate. So heart rate is uh, basically counted as ratio scale. There are certain reason behind it. Suppose someone is having 100 heart rate, it is exactly double of 50 heart rate, right? So it is a ratio scale. There is a definite ratios. So ratio scale are having absolute zero, such as Kelvin scale of temperature. It is the ratio scale. Next, another scale comes called time to event scale. Most of the literatures doesn't describe time to event scale as a type of the scale, but should be considered as a type of scale. Why? Because it is a special type of data, doesn't come under the domain of either type of categorical or numerical. This scale is particularly used when we are interested to measure some time to event activities. So for an example, in a cancer trials, if you are wanted to have some idea whether a particular drug is effective in reducing or improving the survival time of a patient or not. Suppose there are two arms of your clinical trial. One arm is treated with drug A, another arm is treated with placebo. So you are measuring these cases of breast cancer in both the arms for about 5 years, and you are seeing that in drug A arm, some time to event data that you have collected throughout your clinical trial, and you are seeing that this time to event data are segregatedly more in drug A rather than placebo arm. It means that your drug is acting more than placebo for improving the lifespan of those breast cancer patients. So there is a special type of analysis called survival analysis to understand the time for survival in both the arms, and there is a particular curve for this data visualization called Kaplan-Meier curve. Okay, we will talk about this survival analysis in later part of the advanced biostatistics, but for now you just remember that there is a data type called time to event data type. This data type or this scale is used when you are particularly interested in measuring the time taken for an event to be occurred. Now let's have a brief idea about what is variable and what is attribute. Variable is a characteristic or property that can vary. Suppose our age can vary with time, right? You cannot have any control over the age. It will increase only with the time, meaning it can take on different values in different situation or for different subjects. In research, variables are the phenomena, characteristics or attributes that are being measured or studied. Variables can be classified into different types such as independent, dependent, categorical, numerical. Categorical and numerical variables is as same that we have discussed in the data types or scales. And what is an attribute? Attribute is a specific value or quality of that variable can take on. Suppose for an example, gender, if gender is the variable, then its attributes are the males and females. So variables are having certain subset possibilities of individual data, which is known as attributes. What are the types of the variables? Types of the variables can be classified into two distinct concepts. One is as per their continuity, another one is as per their dependency. For as per their continuity, we may divide it into continuous and discrete variable. Again, continuous variables are those which are having continuous numbers, and discrete variables which are having absolute numbers. And dependency, dependent variable and independent variable. So I will encourage you to understand this second concept in a better way, the dependent and independent variables, because in advanced statistical cases we have to understand these two concepts in a very detailed manner. At least this concept should be clear to your mind for analysis like ANOVA, regression, correlation, all of these advanced statistical figures. So continuous variables, we know height, weight, age, blood pressure, etc., etc. And discrete variables where absolute numbers are possible. It may be dichotomous like male, female, to trichotomous like Malay, Chinese, Indian, and multichotomous like Jersey numbers. Okay, and as per dependency, it is a very relative term which will be called independent and which will be called dependent. So as per your convenience of the statistical analysis, you are labeling a variable independent or dependent. How? Suppose the age is the dependent variable. Dependent on whom? On time. Suppose I am getting overweight. So if this is a dependent variable, then it has to have some dependency over something. That is independent variable. So it is a very relative that my overweightness is dependent on my diet habit, right? In this case, weight is dependent, diet habit is independent. But what if I am saying that diet habit is also dependent on my working style, on my desires, on my fascination to take the junk foods? So it is a behavioral factor. So diet is also dependent on the behavioral factors. And if I am taking two variables like diet and behavioral factors, here diet is the dependent variable and behavioral factors are the independent variables. Now, if I am taking two variables like behaviors, which is depending on my upbringing, my societal status, my educational status. So here my dietary habits were dependent on my behavioral factors, but my behaviors are dependent on my education, societal status, and upbringing. In this case, my behavioral factors are dependent variables and my societal status, education, upbringing, those are independent factors. So see, if we really take two variables, depending on their status, we can label them either dependent or independent. So dependency is a relative term. You have to think that what set of two variables or three variables you are taking for your analysis and label them as per your convenience, as per their rationality, that who could be dependent, who could be independent. So thank you very much for going through all these set of lectures on data, scales and variables. But for takeaway message, I want to tell you that data is something which describes any phenomena, any information around us, or in the clinical trials, or in the study of your interest. Scales are something which labels that data as per our convenience of statistical analysis. And variables are something which vary. It may be continuous or discrete, it may be dependent or independent. Also, like scales, variables are important for advanced statistical data analysis. Thank you.